So our next problem is number 34 in section 4.2. And I would encourage you to look this problem up in your book so you can get a bit better picture. But you're given a picture of the graph of a function g of x, and you're asked to compute a couple of different integrals. And you need to remember that there is a connection between the definite integral and the area under the curve. So for this first one, we're computing the definite integral from 0 to 2 of g of x. And that corresponds to the area under the curve between 0 and 2. And since it's falling above the x-axis, we consider this to be a positive integral. So I'm really just asked to compute the area of this pink region that I just colored in. So the integral from 0 to 2 is equal to the area of the pink part. So computing the area of the pink part is really just computing the area of a triangle. And so we want to remember what the formula was for the area of a triangle. The area of a triangle is 1/2 base times height. So in this case, the base of our triangle has 2 units. So I have 1/2 times 2. And the height of our triangle is just this height on the y-axis, which is 1, 2, 3, 4. So times 4, multiplying that all out, I get 4. So that's going to be my answer for part A, is just 4. So the next one that I'm going to look at is the area from 2 to 6 of our function g of x. And that corresponds to the area I'm about to shade in green. So if you look at the write-up of the problem in the book, they do tell you that that green shaded area corresponds to a semicircle. Now, because that green shaded area is lying below the x-axis, we actually have, for our definite integral, the negative of the area of that half circle. So in this case, I'm going to go equals negative the area of the green part. And we want to remember what the area of a circle has for its formula. So the area of a circle is pi r squared, but here we're just taking half the circle. So our result is going to be negative 1/2 pi r squared. And that 1/2 is coming from the fact that it's just half the circle. So to figure out what the radius is, we look at the picture. This circle is centered here, and it goes down 2 and right 2 and left 2. So that means the radius is actually 2. So here I'm going to have negative 1/2 pi times 2 squared. So that's going to be negative 2 pi as our result. And then the last one that they ask for is the full area from 0 to 7. So the full area from 0 to 7 is the pink area plus the green area plus this black shaded region, which I'm about to color in. So this small triangle here is also going to have its area added. So I have, for my area from 0 to 7, the area of the pink part plus, or actually minus, I guess in this case, the area of the green part, because that part lies below the x-axis. And then we're going to add back in ooh, that black marker is not very good. Let's see if I've got another one. Ta-da. Okay, so plus the area of this black triangle. So I already figured out the area of the pink and the area of the green in the previous two parts. So I'm going to have 4 minus 2 pi plus whatever that black area is. So the black area corresponds to the area of a triangle, which is 1/2 base times height. Here the base is 1 and the height is 1. So I end up with 4 plus 1/2 minus 2 pi. You write that as 4.5 minus 2 pi. So just a quick recap of how we approached these problems. So we're given the picture of the graph and we're asked to compute some different areas. And the way that we compute each area is by identifying some kind of a geometric figure that corresponds to that shape. So when I look at this graph, I immediately start to break it up into pieces where I know I could compute the area. So that's why I would break it up into this triangle and semicircle. So you can think about how you might be able to combine different types of shapes. Maybe you have a semicircle, a triangle in between, and you would be asked to figure out that area. Well, you break it up based on those shapes, compute the area of each piece, and that allows you to then compute the total area. A really important thing to point out, too, is that whenever you're below the x-axis, that's actually going to be a negative when you're computing it with area. So that's why down here we have this negative 2 pi. That's something that's really easy to forget. I know I've forgotten it before. So yeah, that's problem number 34, and I'll see you guys next week.